Hey everyone, welcome to this tutorial on how to create some random data and plot this very simple but very efficient line graph. So what I'm going to do here is just to show you how to use one of the functions to create some normally distributed variates, and then we're going to the plot. So I do not have a special package here for this tutorial. I'm just using RBase and RBase only. So I trust that you know how to start creating your script file. I have my script here already written just to save us some time. And the first thing that I'm going to do is to create my random variates. So I'm going to use just an example here of man's height. So I did a little research. It looks like in Canada, the average or the mean height of man in 2019 was 68 inches with a standard deviation of 3 inches. So my sample size here is 100. It's just a number that I'm using for the example. So the first thing that I want to do is to create an object. I'm going to call it man underscore age for height. And then I'm going to assign to this object this distribution, this normal distribution. And I'm using this function here, rnorm. So rnorm will actually return from my syntax here the distribution that I want to see. So in this example, I'm using 100 as sample size. So the very first thing in this rnorm function is the sample size that you want to randomly create data on, and then your mean, and then your standard deviation. So if I just simply type this here just to show you, as I type with the autocomplete, you will see here that RStudio is telling you rnorm. It's asking for n, which is how many data points you would like to see, and then the mean and the standard deviation. So that's exactly what I did here. Let me just delete this to keep it nice and clean. I'm creating 100 data points randomly with a 68 as mean and 3 as a standard deviation. So I'm going to go ahead and run this code. As a reminder, when I use the hashtag, that line is not being executed. That line is going to be ignored by RStudio. It's just a comment that I'm making. So let's run this first line here, line 4. You can click on the button run or just hit Control Enter. You will see that on the right side here in my global environment workspace, I have now my vector, my values in man underscore age, numeric from 1 to 100, that's what I asked, and then the data points that are randomly created based on the normal distribution. If I simply run that object there, you will see in my console that that's what I have. I have from 1 to 100 data points. Those are variants or just numbers that RStudio created randomly. If I wanted to check the class or the type of data this is, although I already know because I saw the num here for numeric, but if I click and run that code class, I will see that this is a numeric type of data. So all good. The same thing I'm going to do for man's weight. Again, I'm using the sample size of 100. The mean in this case is 180 pounds, and the standard deviation is 10 pounds. Same idea. I'm going to assign to an object called man underscore w for weight, and then the rnorm again, randomly create me variates or numbers that are normally distributed. I want 100 data points, and I want the mean to be 180 and the standard deviation to be 15. So if I again run this code, you would also see that on the right side I have my new vector, my new set of values, which is man underscore weight, and again from 1 to 100 my randomly created numbers. So if I simply run that object just to see what's in it, Same idea. Now I just have bigger numbers because I use the mean of 180, standard deviation of 15, but that's my data set. And once again, if I run the class function, I will know that it is indeed numeric. All good. The other thing I can do, although I don't need to do this for the plot, I can create a data frame. So I'm going to call this data frame df, just the name of the object. You can call it anything you'd like. You can call it avocado if you like. And then I'm going to use that less than dash, that sign, to assign information into this data frame. So the function is actually called data frame. And I'm going to grab the man underscore age and the man underscore weight, my two vectors, and I'm going to create this data frame using those two vectors. So now what you see on my workspace here is data. I see my df, my data frame, 100 observations of two variables. That makes sense. And if I run my head function, just to see the first 6 rows in my data frame, recently created, called df, I will see that I have first the records that RStudio adds, and then I have man age, man w, man height, and man weight, and then my numbers. All good. The only other thing I want to create here is just a sequential time series, just for my plot. I wanted to maybe say, you know, I recorded my weight over a few years and I want to see that on my line plot. I'm going to create, in this case, an object called OBS for observations. Again, you can call it observations, you can call it anything you'd like, as long as you don't call it something that it's already a function. For example, you don't want to call it ls or data frame or lm for linear model or plot, so you don't want to give those names. But other than that, you can create the name you'd like. The function that I'm using here is the sequence function, seq, and I'm going to create as date, and this date is the date that I picked. I just selected, you know, January 1st, 2010, comma, and I want it by month, so that's important, comma, and I want the length out, this is another function, very cool actually, to be 100. Why 100? Because I have 100 data points for weight and I have 100 data points for height. I want that to match. So basically I'm saying sequence, create a sequence of dates by month started January 1st, 2010 and length it out 100 times. And you'll see how cool this looks. And then I grabbed all of this and I stuck it into an object called OBS. So if I run this function here, it's not showing me anything because I simply assigned to that object, but if I run the object itself, I will see that I have those dates starting from 2010, January 1st, and then February, March, April, so on and so forth. 100 records, and I know it because the 99th record is right here, and then the 100th record, it's right there. So that's all good, and again, I created this just for my plot. Now, finally, let's get to the simple line plot. How do you grab information such as this and then create a simple, professional-looking, clean line plot? Well, the function is very simple. Plot, which is rbase. Once again, I'm not using any special package here. I need to inform, in this case, what goes on my x-axis and what goes on my y-axis. In my x-axis, I want OBS. What is OBS? Remember, that's the object that I created, that sequential dating system there from January 1st, 2010, 100 length out. So I call it OBS. So I want it to be on the x-axis. The y, it's going to be, I just picked as an example, the man underscore weight. The type of plot, is an L for line. And then I added a lot of more cosmetics here. So let me run this first so you can see how it looks. And then I'll walk you through the cosmetics. Okay. So as you can see here, I have my X observations, my data series on the X axis. And then the weight in pounds on the Y axis. It's a line type. The line type is solid. I could, for example, make a dash, run it again, and now it's a dashed line plot. Or you can use dotted. Different options you can search up. I kind of like the solid in this case. And then the line width, I can make it thicker. Right now I have 2, but if I change to, sorry about that, to 3, it's a little thicker, so that's the line width, LWD. The color, our base has so many beautiful different colors. I keep kind of picking them just to try it out. This one here is the Aquamarine 2. At the end of the line I have a comma, and then I'm adding more to the graph. A title, which is the main equals man weight over time, which is the title that you see here. The color of the main, the color of the title, in this case it's black, comma at the end of the line. The X label, or the X lab years, as you can see on the plot. The Y label, weight in pounds, and this is text. It's within quotation, I can write whatever I want. The color of the label is dark green. The font of the label is 2. So the font works this way, 1 to 4. 1 is regular, 2 is italic, 2 is bold, 3 is italic, and 4 is italic bold. So for example, if I change this to 4, and that's for the label, you'll see now that it's italic bold. If I change it back to 1, for example, it's just a regular font. And then I have the CEX. The CEX is the character expansion rate. In other words, the size of the font. So this is 90%, 0.9 of the regular size. So that's customizable too. So all of this coding here really is, all the way to here, really is the cosmetics. Again, you want to make your plot look good, look professional, and you're just adding different things, and the titles, of course, the axis information, everything looks good. I see the years, I see the weight in pounds. It's a good looking, professional, neat line plot. The last thing I wanted to add, and this is a very cool function, it's called AB line. Basically, I'm adding a line at the horizontal point of 180, so you can see that my dotted red line, it's a one straight line of the 180 pounds. Say for example that my goal was 180. I just wanted to see over time when I was under my goal or over my goal. Obviously this is a normally distributed data set, so it's kind of up and down, but just to make the case here, AB line right after the plot function, horizontal at 180. The color I just chose red, the line type dashed, and then the line width 2. So those are the type of things that you can do with a simple line plot in RStudio. As a reminder, you can always export as an image, as a PDF, or you can copy this plot to a clipboard just by simply clicking here, copy plot. And now you have it on your clipboard. You can paste it on the PowerPoint or in a Word document, whatever the case may be. So this is it. This is how you create a simple line plot from randomly created numbers in RStudio. I hope you've learned something here, and I hope to see you again soon.